Hello everyone, welcome to Math World. This video is to discuss Paper 3 Binomial Expansion Part 2. Okay, so here we will solve more challenging questions. So the first one is express fx equals to 6 over x squared minus 3x minus 4 in partial fractions. Okay, this is the first part. Then after that, A. Obtain an expansion of fx in ascending powers of x up to and including the term in x cubed. Okay, so then B. Obtain the expansion of the same function in ascending powers of 1 over x up to and including the term in 1 over x cubed. So firstly, we need to solve partial fractions. Right? So now fx equals to 6 over the quadratic function. Now, first of all, to get the partial fractions, we need to have minimum 2 linear factors, or I would say minimum 2 factors in the denominator. Okay, so from here, the quadratic function or quadratic factors, the quadratic function can be factorized into x minus 4 and x plus 1. Okay, so then from here, before we find the partial fractions, we have to check is this proper rational function. So when you look at the numerator, there's only 6, which is a constant. So therefore, this is the proper rational function, and hence we can just direct find the partial fractions. Now, for the partial fractions, we will look at the denominator. So since the denominator consists of 2 linear factors, therefore we will just write constant over first linear factor plus another constant b over second linear factor. So now we need to get the same denominator by comparing the denominators on the left hand side. Therefore, it will be a over x minus 4 multiplied with x plus 1 over x plus 1 plus b over x plus 1 multiplied with x minus 4. Okay, over x minus 4, because we need to get these two denominators. Once you obtain it, then you just refer to the numerators. So my numerators, you can just cancel off all the denominators. So my numerators will be just 6 equals to a times x plus 1 plus b times x minus 4. Okay, and now to get the a and b, let the factor be 0, right? Firstly, I will let x plus 1 be 0, therefore x equals to minus 1. So you substitute this x equals to minus 1 into the previous expression. Therefore, this is going to be 6 equals to, now whenever you say x plus 1, that will be 0, because just now I let x plus 1 be 0. So the first term will be 0, and now b bracket minus 1 minus 4. Which means now here my b is basically minus 6 over 5. Okay, then now let the second factor be 0, which is x minus 4 be 0. Hence, my x is 4. So left side 6. Then first term a bracket 4 plus 1. So basically 4 plus 1 is 5. So I will be getting a equals to 6 over 5. Okay, so now I will just need to rewrite my partial fractions. So substitute the a and b in this expression or in the partial fractions, then that will be your solution. So then just for information, by right we write in this form. Okay, plus minus 6 over 5 over x plus 1. But basically we don't write in this form. So what to do is, the simplest form is this 6 over 5. Since it's a fraction, I will just move it down. So it becomes 6 over 5 times this fraction. Okay, then the plus and minus, simplify it into minus. So here becomes minus 6 over 5 times 1 over x plus 1. So this will be your partial fractions. So done for the first part. Okay, so by referring back to the question, A is expressed the expansion until x cubed. So I'm going to use this form for the expansion. So what to do is A, your fx, it is 6 over 5. Now, since the x minus 4 in the denominator, so you have to move up. So when I move up, I will rearrange so that the x is the second form. If you still remember the formula, okay, 1 plus x degree n equals to 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1 times n minus 2 over 3 factorial x cubed. So this will be the expansion. Now our concern is must get 1 and followed by plus. Okay, therefore now instead of writing x minus 4 power negative 1, I will change to minus 4 plus x power negative 1, so that the x is always the second term. And same goes to the next term, which is 6 over 5. Then instead of writing x plus 1 degree negative half, you just write 1 plus x degree x plus 1 degree negative 1. Then you just write 1 plus x degree negative 1. Okay, so then now, again, make sure it is 1 first for the first term. So I have to factorize minus 4 for my first expansion. This is going to be 1. Now, the second term, when you divide by minus 4, that is going to be negative x over 4. Because when you factorize, it's like you are dividing that value. Okay, so then again, there are two terms with degree minus 1. So the minus 1, you bring it into the two terms first. I'll do all this first before I do the expansion. And at the same time, make sure it is plus. Okay, 1 plus x. So now, instead of writing 1 minus x over 4, it becomes 1 plus negative x over 4. Then degree minus 1. Okay, then minus 6 over 5 bracket 1 plus x degree minus 1. And now I can start doing my expansion using this formula, the expansion formula. So what to do is, okay, minus 4 degree minus 1, that is minus 1 over 4. So here I will write 6 over 5 times minus 1 over 4, and then followed by the expansion using this formula. Now, go back to the question. We need to expand until x cubed. So my x cubed, just use these must get these 4 terms. It will be 1 plus, my n now is minus 1. My x is negative x over 4. Okay, this is my x. My x has been changed to minus x over 4. That is my new x. Then minus 1 times minus 2 over 2 factorial minus x over 4 degree 2 plus minus 1 minus 2 and then minus 3 over 3 factorial times minus x over 4 cubed. Okay, this is for the first expansion. Followed by the second expansion is minus 6 over 5 bracket, or I just use square bracket. 1 plus, my n is minus 1, my x is x. This one is easy. So minus 1 minus 2 over 2 factorial. Actually, just use this formula directly and replace the n by minus 1. Okay, then here is going to be x squared. Then plus minus 1 minus 2 minus 3 over 3 factorial times x cubed. Okay, so simplify all the terms inside the square bracket first. So it's going to be the first one, you get 6 over 5 times negative 1 over 4, that is going to be negative 3 over 10. Okay, multiplied with 1 plus x over 4, just do expansion. So here, simplify, all this simplify. Alright, so you will be getting x squared plus 16, x squared over 16, sorry, plus 1 over 64 x cubed. Okay, and for the next expansion, it's going to be minus 6 over 5. So 1 minus x plus x squared minus x cubed. Then now just do expansion again. Bring in the constant to the square bracket. Then from here, you will be getting minus 3 over 10 minus 3 over 40x minus 3 over 160 x squared minus 3 over 640 x cubed. Okay, all multiplied with minus 3 over 10. And then followed by minus 6 over 5 multiplied to the whole bracket. That means this is going to be minus 6 over 5 plus 6 over 5x minus 6 over 5x squared plus 6 over 5x cubed. Okay, so lastly, just simplify. Constant, simplify with constant. So combine these two terms. This is going to be negative 3 over 2. And then followed by 9 over 8x minus 39 over 32x squared plus 153 over 128 x cubed. Okay, so this is the expansion up to x cubed for fx. Now b, same function, but then now we need to expand for the terms of 1 over x, right? So that it will not be x anymore. It will be just 1 over x, 1 over x squared, and so on. And now we need to get the term up to x, 1 over x cubed. Use back the same function. So what to do is I'm going to copy the same fx, which is here. So my b fx equals to 6 over 5 minus 4 plus x degree minus 1, then minus 6 over 5 1 plus x degree minus 1. Okay, so be careful with this expansion now because we need to get 1 over x as a term. So if you need to get 1 over x as a term, you must have the term of 1 over x. Okay, which means now instead of this formula, right, this one you must get 1 over x. So what to do is instead of writing the x over here, I have to factorize the x. So now here becomes 6 over 5. I factorize the x. Then when I factorize the x, okay, the first term will be minus 4 over x, then plus 1. Minus 6 over 5. So to get the 1 over x in the bracket, I have to factorize x. So the first term becomes 1 over x, second term is plus 1. Okay, now I have to arrange so that it is in this form. First term is 1. So now, again, I will bring in the power first. Alright, so bring in the power for both of the terms. So that is going to be 6 over 5, x degree minus 1. Then now instead of writing minus 4 over x plus 1, degree minus 1, now I need to arrange so that the first term is 1. So I will rearrange it. So minus 4 over x, I will just write 1 minus 4 over x is the same. Minus 6 over 5, the x power negative 1. Then after that, 1 plus 1 over x power negative 1. Okay, then from here, the x power negative 1 is basically 1 over x. So I will write 6 over 5 times 1 over x. And then instead of minus, I change to plus, right? So if you want, in the previous step, you can just direct write 1 plus. Then here minus. It's the same. So then use the formula. And now, if you look at the question, we need to get 1 over x cubed, which means it will be 1 plus, now my n is minus 1. So minus 1 x is negative 4 over x. Then plus n minus 1 over 2 factorial. My new x is negative 4 over x. Then you square it. And then plus minus 1 minus 2 minus 3 over 3 factorial. Then minus 4 over x cubed. Okay. Stop the expansion. And now followed by the next one. 6 over 5. Again, x power negative 1 is 1 over x. Then 1 plus 1 over x power negative 1. So now your x here becomes 1 over x. We use back the same formula. The n is minus 1. 1 over x plus minus 1 minus 2 over x squared. Then 1 over x squared. Okay, so now you see the question asking for 1 over x cubed. I didn't realize that the previous expansion actually we do need the third term, because in your expansion over here you have x in the denominator, which means actually this term is not needed. Okay, so you can just ignore it. So then here plus dot dot dot. Alright, so which means now here I will just simplify 6 over 5x times, okay, simplify these three terms inside the square bracket. It will be 1 plus 4 over x plus 16 over x squared. Then minus, and again here, just simplify. Okay, after that, simplify the terms inside the bracket. That is going to be minus 6 over 5x multiplied with 1 minus 1 over x plus 1 over x squared. Okay, so then now again expand. Do expansion, multiply, multiply. Then the first bracket will give you these four terms, these three terms: 6 over 5x plus 24 over 5x squared plus 96 over 5x cubed. Okay, the plus dot dot dot, ignore it first, then just combine with the second expansion. There is going to be negative 6 over 5x plus 6 over 5x squared minus 6 over 5x cubed. Okay, so then from here, I can simplify all my terms. First and fourth term will be cancelled off. Okay, then you will be getting 24 over 5x squared plus 6 over 5x squared. So that is going to be 6 over x squared. Alright, and then the 96 over 5x cubed minus 6 over 5x cubed, that is simplified into 18 over x cubed. Okay, but then the question asking for in 1 over x cubed. So to show clearly, okay, so you can just write this is basically 6 times 1 over x squared plus 18 times 1 over x cubed. So this is our expansion. Same function, but then you will have two types of expansions. Right, so done for the first question. Okay, now let's move on to question number 2. So obtain the first four terms in the expansion in the ascending powers of x for this square root of 4 plus x over 1 minus 2x. State the set of x values for which the expansion is valid. Okay, then by putting x equals to 1 over 14, show that square root 19 approximate to this fraction. Okay, which means we are not using calculator to get the fraction, but we are using expansion. So for this case, since we need to get first four terms of the expansion, firstly, I must express in 1 plus x degree n. Okay, so I rewrite the question. I move up the denominator. This is going to be 4 plus x and 1 minus 2x, both degree. When I move up, the 1 minus 2x is power negative 1. And then both with degree half because of square root. And then we have a formula, AB power m, that is going to be A degree m, B degree m. Okay, just bring the power. Bring in the power. So this is going to be 4 plus x degree half times 1 minus, okay, since this is minus, right, or probably you can just write minus first, do it step by step. Then again, for the formula, it must be 1 plus x degree n before you do an expansion. So instead of 4, factorize the 4 first, make it to 1. So then the second term becomes x over 4. Now degree half. Multiplied with 1 plus minus 2x degree of negative half. Okay, so then the degree half for the first term bring in, that will be 4 power half. Then 1 plus x over 4 degree half multiplied with 1 plus negative 2x degree of negative half. Okay, so alright. So then from here, 4 degree half is basically 2. And now we can just start our expansion. So we need to get first 4 terms. Alright, that is our concern. First 4 terms. Use the formula 1 plus, now my n is half, my x is x over 4. This is my second term. Plus third term, half, then half minus 1. That is minus half over 2 factorial. Then after that, the new x degree 2. Plus, we need fourth term, or we need 4 terms, right? So this is my fourth term. So minus half. Now this minus half minus 1, it will be negative 3 over 2 over 3 factorial. Then x over 4 cubed. Okay, done for the first 4 terms. Now multiply, okay, times with 1 plus n is negative half. My x now is negative 2x. Okay, when you look at here, this is my n. This is my new x. Therefore, negative 2x plus half, negative half. So negative half minus 1 is negative 3 over 2 factorial. Negative 2x squared plus negative half, negative 3 over 2. Then this value, negative 3 over 2 minus 1, that is minus 5 over 2 over 3 factorial. X negative 2x cubed. Okay, so this will be the binomial expansion, and then now just simplify all the terms. So firstly, the first brackets, you simplify all the terms first. It will be 1 plus x over 8 minus 1 over 1 to 8 x squared plus 1 over 1024 x cubed. Then multiply with, okay, so simplify all the terms inside the second square brackets, all these terms. So this is going to be 1 plus x plus 3 over 2 x squared plus 5 over 2 x cubed. Okay, and then now here, since we need to get first 3 terms, first 4 terms, that means it will be up to x cubed. Okay, so now when we do expansion right now, so this one multiply to all these terms to get x cubed. Then when it comes to the second one, it will be less term. So because this is x degree 1, so I just need to expand until x squared here. I mean, you multiply to the 3 over 2 x squared, that will be the x cubed, which is our fourth term. Okay, no need to do the full expansion. So now I will be getting 2 bracket 1 plus 1 times all the terms in the second bracket. Just rewrite all the terms. Okay, then the x over 8 just multiply from 1 until 3 over 2 x squared. So you will be getting x over 8 plus x squared over 8 plus 3 over 16 x cubed. Okay, then same goes to the next one, okay, which is here. This negative 1 over 1 to 8 x squared just need to multiply up to second term, because we will stop our fourth term will be x cubed. Okay, so this is going to be negative 1 over 128 x squared, and then minus 1 over 128 x cubed. And lastly, just multiply with 1. Okay, plus 1 over 1024 x cubed. So this will be our expansion until x cubed. Now, simplify all the terms inside the square bracket. So you will be getting 1 plus 9 over 8x plus 207 over 128 x squared plus 2745 over 1024 x cubed. So at last, all these terms multiply by 2. That is 2 plus 9 over 4x plus 207 over 64 x squared plus 2745 over 512 x cubed. Okay, so done for the expansion. Okay, A, set. State the set of x values for which the expansion is valid. So now since we have done 2 expansions, see this is the first one. Okay, first expansion, second expansion. So now we need to consider modulus of their x. So now I will just write here. Okay, A, 4 plus x degree half. This is 2 times 4 plus x degree half, that is going to be 2, okay? Because this 4 power half is 2. 1 plus x over 4 power half. Okay, then another one is 1 minus or 1 plus negative 2x degree negative half. So I will just write modulus x over 4 less than 1. This one is modulus of negative 2x less than 1. Then now modulus x less than 4. So from here, 2 modulus x less than 1. That means modulus x less than half. Okay, now we have 2 inequalities now. So we need to find out the smallest interval, okay, for which it will be satisfying both expansions so that the final expansion is valid. So which means now here, basically if you can't imagine, okay, I will just draw it out. So that means this is between minus 4 and 4. The other one is between minus half and half. Okay, basically by inspection we know that it is less than half. It's the smallest. So if you can't imagine, so you can just draw it out, draw the number line. Okay, so the first one will be here, the longer one, and the shorter one is over here. So obviously, the one that satisfies both is the shorter one, the smaller one. So therefore, I will just write the expansion is valid when modulus x less than half. Okay, or probably you can just refer to these two and take the smaller one. So therefore, the answer is modulus x less than half. Without showing the number line. Okay, so that's all for this question. Now B, putting x equals to 1 over 14, show square root 19. So this square root 19, actually we get it from square root 4 plus x over 1 minus 2x. So now part B. Okay, I will rewrite this. Okay, so now your x is 1 over 14. Okay, so when I let x be 1 over 14, my substitution. Okay, so now here you check square root 4 plus 1 over 14. Or probably here I will just copy down the expansion first. That would be better. 2 plus 9 over 4x. Okay, so based on this expansion, we will replace the value accordingly. So this is going to be 1 over 14 over 1 minus 2 times 1 over 14 equals to, or I will write approximate because this is not the full expansion. Okay, approximate to 2 plus 9 over 4 times 1 over 14 plus 207 over 64 times 1 over 14 squared plus 5745 over 512 times 1 over 14 cubed. Okay, then now when you simplify, the left hand side here, basically that is square root of 19 over 4. Okay, and then for the right side, since we need to get the fraction as the final answer, so you have to leave your working in fraction. So when you simplify the terms, you will be getting all these terms. Okay. Then now, this square root 19 over 4, I can change it into square root 19 divided by 2. Okay, and now here for the right side, since we need to get our final answer as the fraction, so you have to make it to all same denominators. So I make it to 1404928 denominator. So that means now 2 multiplied with the denominator, so get 2809856 plus 9 over 56 times 1404928. So that is 225792. And the next one is 23184. Lastly, just copy 2745. Okay, then from here, I simplify the right side first. This is going to be 3061577 over 1404928. And now the over 2 in the on the left hand side can be moved up. Okay, or you can say I multiply the whole equation by 2. So square root 19 approximate to 2 times 3061577 over 1404928. Then now, when you simplify, this is going to be 3061577 over 702464. Okay, so this is our fraction, right? So this is how we approximate the value using binomial expansion. Okay, now let's move on to next question. Question 3. Given that 2 plus ax over square root of 1 minus bx equals to 2 plus 25 over 4x squared, and the rest of the terms can be ignored. Okay, A, find the possible values of A and B. B, with the values of A and B in parts A, state the set of x values for which the expansion is valid. Alright, so now what to do is A, 2 plus ax over square root of 1 minus bx. Alright, so then as usual, since I have the x in the denominator, I will move up. This is 2 plus ax multiplied with 1 minus bx to the power of negative half, because the square root itself is power half. But since this is the denominator, when you move up, it becomes negative degree. Okay, so as usual, make sure it is 1 plus first. So I will rewrite. Now, first term, 2 plus ax is with degree 1. So we are not going to expand it. Therefore, just rewrite. Then I will write 1 plus negative bx, degree of negative half. Okay, so the expansion is for the second term, it's not for the first term. So this is going to be 2 plus ax. Then use a formula. And now you see here, it is up to x squared. So I will be doing the expansion up to x squared only. So it will be 1 plus n is negative half, x is minus bx. So this is 1 plus nx plus n minus half minus 1 is going to be negative 3 over 2 over 2 factorial minus bx squared. Okay, and plus dot dot dot. So our constant is up to x squared. We need to expand out to x squared because the first term here is constant, which is 2. So the expansion must be up to x squared, otherwise you won't get the complete expansion. So from here, the next step is going to be just simplify all the terms inside the square bracket. Then you will be getting 1 plus half bx plus 3 over 8 b squared x squared. Okay, now for all the terms, you just do the expansion first. So that means the a multiplied with the bracket, then followed by the ax multiplied by the bracket. So when you do expansion, ax with the brackets, since we are interested up to x squared, so you can just expand up to half bx. So which means now here I will be getting 2 plus 2 times half bx, that is bx, plus 3 over 4 b squared x squared. Okay, so now the ax multiplied to first two terms. So that is ax followed by half abx squared. And I will group them now. Okay, so the only constant here is 2. Then when you refer to the coefficient of x, right, here you have b, you have a. Then now from here, I will just write plus a plus b times x. And same goes to the remaining terms, factorize x squared. So you will be getting 3 over 4 b squared plus half ab, both multiplied with x squared. Okay, so that's all for our expansion. And now, since the two terms are given, so you are going to compare. So I will write equals to 2 plus 25 over 4x squared. Okay, you are given these two terms in the expansion. So when you do comparison, right, that means, so here by comparing the coefficients, because the first term is the same, the coefficients of x, coefficients of x, that means a plus b equals to 0. So no need to write a bracket here. So I will be getting a plus b equals to 0. Therefore, I will write a equals to minus b. And then the x squared. So 3 over 4 b squared plus half ab, which is here, it will be same as positive 25 over 4. Okay. And then now, second equation. So substitute first equation into second equation. I will be getting 3 over 4 b squared plus half. My a is replaced by minus b. Then multiply with b. This is 25 over 4. And now from your, when you do expansion, this is going to be 3 over 4 b squared minus half b squared equals to 25 over 4. So simplify, it will be 1 over 4 b squared equals to 25 over 4. Then my b squared, obviously the 4 can be cancelled off from both sides. So b squared is 25. Therefore, my b is going to be plus minus 5. Okay. So then now, when my b, okay, so when b equals to plus 5 from 1, my a is minus of 5. That is minus 5. So when my b is minus 5, my a is going to be minus of minus 5. That is 5. Okay, so now here I get two sets of a and b, which means my a is minus 5, b is 5, or a is 5, b is going to be minus 5. Okay, so find the possible values of a and b. Alright, so done for this. Now, with the a and b values, state the x for which the expansion is valid. Okay, so now I will have to rewrite. So for the parts b, because my fx, did I write fx here? No, 2 plus ax. Okay, so I will write 2 plus ax over square root 1 minus bx. This is my expansion. So when my a is 5, okay, when my a is minus 5, sorry, when my a is minus 5, b is 5, okay, so my function, okay, let this be fx. So better let this be fx. So my fx is 2 minus 5x over square root of 1 minus b. So it becomes 1 minus 5x. Okay, so this is when a equals to minus 5 and b is 5. So when my a equals to positive value, my b is minus 5. Okay, as we have found in the previous part. Now my fx becomes 2 plus 5x over square root of 1 minus 5, that is plus 5x. Okay, so when it comes to expansion, so remember just now, we just did one expansion, which is from the second term, okay, the denominator. The first term, because it's degree 1, no expansion involved. So which means, now I will just check the denominator, which means this is 2 minus 5x times 1 minus 5x degree minus half, or the second one is 2 plus 5x times 1 plus 5x degree minus half. So the expansion is valid, okay, the expansion, or probably I will just write this later. Now, for your information, the expansion is valid when it is the modulus of the x is less than 1. So which means the first one, I'm going to write this out. 1 plus negative 5x power negative half. Okay, so when I take modulus of 5x less than 1, and for the second one, it's going to be this modulus less than 1. Basically, both will be giving you the same answer, because the first one, modulus of minus 5x, is basically the same as modulus of positive 5x. Because the modulus means absolute value, therefore it will be always positive. So now here I get the same. Okay, so which means my modulus x is less than 1 over 5. Right, because the step-by-step working is going to be 5 modulus x less than 1. Therefore, modulus x less than 1 over 5. So same goes with this. This will be modulus x less than 5, which means the expansion is valid when modulus x is less than 1 over 5. Okay, so this is how we solve this set of x values for which the expansion is valid. Okay, so yeah, I think that's all for the solution of this question, and it has come to the end of the video. Alright, thanks for watching. If you enjoy watching my video, please share and subscribe. Please subscribe to the channel and share this channel with your friends, and also stay tuned for more upcoming videos. Thank you everyone. Bye.